Hi guys, in this video I want to look at how resistors work. Resistors are devices that limit the flow of current. They are designed to introduce a known value of resistance into a circuit. Every electrical appliance has a current rating. If too much current passes through it, it burns out. To prevent electrical components from burning out due to excess current, resistors of the correct size are connected in a circuit. Let's calculate the value of this resistor we have used in this circuit to prevent the light bulb from burning. The light bulb has a resistance of 10 ohms, a current rating of 0.5 amps, and is connected to a 12 volts battery. We need first to find the total resistance required to have a current of 0.5 amps flowing in the circuit. Using Ohm's law, resistance is equal to voltage divided by current, which is 12 volts divided by 0.5 amps, we get 24 ohms. We need 24 ohms in the circuit to prevent the light bulb from burning, or for 0.5 amps of current to flow in the circuit. Since the light bulb has a resistance of 10 ohms, and we need a total resistance of 24 ohms, then the resistor has a resistance of 14 ohms. Resistors come in different shapes, sizes, and types, but their general construction consists of a resistive material with two terminal wires connected at the ends of the resistive material and then covered with an insulating material. Resistance of a resistor is measured in ohms. The resistance value of a resistor is determined by four factors that are the type of the resistive material, temperature, length of the resistive material, and the cross-sectional area of the resistive material. We have already talked about these factors that affect the resistance of a resistor in the video What is Resistance? The length and cross-sectional area of a resistor can be fabricated in many ways, usually by making some cuttings in the resistive material so that the desired resistance value of a resistor is achieved. Resistors are color or letter digit coded, which represents the resistance value and tolerance of a resistor. In color coding, the resistor is surrounded by bands of different colors, and in letter digit coding, numbers and letters are printed on the surface of the resistor. Under color coding, we have 4 and 5 color band color coding. In 4 color band color coding, the resistor has 4 colors, each color corresponding to a specific number as shown in the table on the right. The first color on 4 color band color coding represents the first digit value. The second color represents the second digit value. The third color represents the number of zeros. And the last color represents tolerance. If gold or silver is found in the third band, the resistor value is divided by 10 or 100 respectively. When selecting a resistor for a particular circuit, there are factors that are considered so that the resistor will operate as required. These factors include resistor value, power dissipation, power rating, tolerance, and physical size of the resistor. After calculating the value of a resistor as we have done earlier in this video, you then pick a resistor with the power dissipation, power rating, tolerance, and physical size of the resistor needed in that particular circuit. When current passes through a resistor, heat is generated. The maximum heat that can be generated in a resistor before it breaks is its power rating. Power rating is also defined as the maximum power a resistor can dissipate without overheating or failure. The power rating of a resistor is given by the product of voltage and current. In our previous example, we had a 14 ohm resistor connected to a 12 volts battery. The current flowing through it was 0.5 amps. Then power rating is equal to the product of 12 volts and 0.5 amps, we get 6 watts. Power dissipation is the actual power a resistor dissipates in a particular circuit. Power dissipation is given by the product of current squared and resistance value of a resistor. In our previous example, we had a 14 ohm resistor, and the current flowing through it was 0.5 amps. Then power dissipation is equal to the product of 0.5 amps squared and 14 ohms, we get 3.5 watts. Tolerance is the amount by which the resistance of a resistor varies from its stated value. For example, this 2200 ohm resistor has a tolerance of plus or minus 5%. Plus or minus 5% of 2200 is equal to plus or minus 110. 2200 minus 110 is 2090. and 2200 plus 110 is 2310. If measuring the value of this resistor and getting the value between 2090 and 2310, it means the resistor is working, but if not, it means the resistor is dead. Some circuits in instrumentation and medical diagnosis need resistors with very small tolerance value so that they give accurate results. Exact values of resistors are not important in most circuits. There are values of resistors that are only manufactured, and these values are put into groups called E-series according to tolerance. For example, the E24 series and E12 series. In the E24 series, we find resistors with a tolerance of plus or minus 5%. After calculating the value of a resistor as we have done earlier in this video, you then go to the series you want and pick the resistor with the resistance value closest to the one you have calculated. Resistors are grouped into linear and nonlinear resistors. Linear resistors are resistors that obey Ohm's law, while nonlinear resistors are resistors that do not obey Ohm's law. Ohm's law states that current in a circuit is directly proportional to circuit voltage, while inversely proportional to circuit resistance when the circuit temperature is kept constant. In Ohm's law, when voltage increases, current also increases, and when voltage decreases, current also decreases, but proportionally. That is, when voltage doubles, current also doubles. A resistor is linear if current through it proportionally increases or decreases with the voltage, but if not, it is a nonlinear resistor. In Ohm's law, temperature is kept constant, since the resistance of all resistors is affected by temperature. In nonlinear resistors, even when the temperature is kept constant, current do not proportionally increases or decreases with the voltage. This is because they have other conditions that affect their resistances. There are also resistors with resistance value that significantly changes with a change in temperature. These resistors are also put into a group of nonlinear resistors. Linear resistors are grouped into fixed and variable resistors. Fixed resistors are resistors with resistance value that cannot be varied. These are resistors manufactured with a specific resistance value. Examples of fixed resistors include carbon film resistors, carbon compound resistors, wire-wound resistors, and more. Variable resistors are resistors with resistance value that can be varied between their minimum and maximum values. Examples of variable resistors include rheostats and potentiometers. Here is a variable resistor with 3 terminals. If we use terminals 1 and 2 as shown, it works as a rheostat. A rheostat is a type of a variable resistor with 2 terminals. It varies its resistance by moving a wiper across a resistive track. If terminals 1 and 3 are used as shown, there is no resistance being varied. The variable resistor is working as a fixed resistor. And lastly, if all terminals are used as shown, it works as a potentiometer. A potentiometer is a variable resistor with 3 terminals, used to divide the input voltage into 2 parts, with the output voltage taken from the wiper. The value of the output voltage or voltage to the load is then adjusted by moving the wiper across the resistive track. In this animation, the potentiometer is used to adjust the brightness of the light emitting diode by varying the voltage across its terminals. With the wiper at the far right end of the resistive track, the voltage across the light emitting diode is 0 and the diode is off. As the wiper is moved to the left, the voltage across the diode increases until it equals the supply voltage, and the brightness of the diode also increases to maximum as you move to the left. Let's look at nonlinear resistors. Nonlinear resistors include light-dependent resistors, thermistors, varistors, and more. Let's look at a light-dependent resistor as an example of nonlinear resistors. A light-dependent resistor is a resistor with resistance value that varies depending on the amount of light falling on its surface. Its resistance decreases as the amount of light falling on its surface increases, and its resistance increases as the amount of light falling on its surface decreases. Light-dependent resistor is said to be a nonlinear resistor because if the amount of light falling on its surface increases, its resistance decreases, resulting in an increase in current while its voltage is not increased. Okay guys, this is what we have in this video. I hope you enjoyed it. See you in our next videos.